For, well, pretty much the last decade, AI has lived this quiet life, just kind of humming away on servers, existing as pure code up in the cloud. But that is all changing. Right now, AI is getting a body. It's moving from being just a digital brain to having a real physical presence, one that's ready to interact with our world. Okay, so let's dive into this massive shift. So, what's the big difference here? Well, think of the AI we're all used to, like ChatGPT. You can think of that as a brain in a vat. It's pure software, just processing information on some server somewhere. It just kind of passively waits for you to give it a prompt. But embodied AI, that's a whole different story. It's an embodied brain. It's software that's actually integrated with a physical body, and it's designed to proactively take action in a physical environment. It really is the difference between just thinking and actually doing. The key thing to get here is that we're talking about any intelligent machine with a physical body that acts in the real world. This isn't just one type of humanoid robot like you see in the movies. Nope. It's this huge category covering everything from the little Roomba vacuuming your floor to a Tesla driving down the highway, and even the giant robotic arms that built that Tesla in the first place. And look, this is not some far-off sci-fi dream. This move from digital to physical AI is already creating a massive new economy. We're talking about a real, tangible economic footprint that's growing at an absolutely incredible speed. Let's actually look at the numbers. To really get a sense of the scale, you only have to look at one company, Amazon. They have over 1 million mobile robots working in their warehouses right now, today. And these aren't just test units. These things are the core of their global logistics network, physically moving the stuff that shows up at your front door. And the growth here is just explosive. The market for embodied AI is projected to hit a whopping $23 billion by 2030. That's a staggering growth rate of nearly 40% a year. That's not just growth, that signals a fundamental shift in how our entire industrial world is going to work. And you better believe investors are taking notice. Confidence is sky high. Want proof? A humanoid robot startup called Figure AI just raised $1 billion in a single funding round. That is a massive bet that general-purpose robots are officially moving out of science fiction and into our reality. Okay, so the numbers are huge, we get it. But what does this technology actually look like in the real world? Let's move beyond the spreadsheets and check out some real-world examples of embodied AI in action today. One of the biggest applications is right here in logistics. Inside these gigantic warehouses, robotic arms and swarms of mobile robots are the new backbone of the supply chain. They work 24/7, sorting, moving, packing. And the result for you and me? Faster, more accurate deliveries. And it goes way beyond logistics. These robots are now taking on the jobs that are just too dangerous for people. They're being sent into disaster zones, nuclear facilities, and volatile industrial sites to inspect damage, check for leaks, and gather critical data, all while keeping human workers safely out of harm's way. And here's an incredible, very specific example, the Rhino Protect firefighting robot. This thing is built to survive extreme heat and smoke, which lets it go right into the heart of a blaze where no human could possibly survive. This isn't just cool innovation. This is technology that literally saves lives. So, how do these machines actually do it? How do they operate in our complex, totally unpredictable world? It seems impossibly complicated, right? But we can actually break down their thinking process into a surprisingly simple loop. Let's take a quick peek inside the embodied brain. It really all comes down to a simple 3-step cycle. First, the robot has to perceive its environment using sensors, things like cameras for vision and LiDAR for depth. Second, it uses all that data to model the world, creating its own internal understanding of its surroundings. And this right here is the game changer. The same kind of incredibly powerful AI that's behind ChatGPT is now being used to create these world models, which lets these robots understand context and plan complex actions like never before. And then finally, based on that model, it will act, making a decision and executing a physical movement. Perceive, model, act. That's the loop. Now, as exciting as all of this is, let's be real. We're not living in some robot utopia just yet. Not even close. Giving AI a body creates this whole new universe of massive challenges. Technical, ethical, and societal. So let's get a balanced perspective here and look at the major hurdles that are still ahead. This quote from way back in 1988 by the roboticist Hans Moravec perfectly captures the core problem, something we now call Moravec's paradox. See, it's actually pretty easy for an AI to do things we humans find hard, like incredibly complex math or winning at chess. But it is unbelievably difficult to teach a robot things a one-year-old finds easy, like just walking on uneven ground or picking up a toy. And the scope of the problem is just enormous. This mind map gives you a sense of the tangled web of issues we're facing. It's not just one thing. I mean, look at the cluster for hardware and infrastructure. We need way better sensors, more efficient power. Then you've got this whole other branch for ethical and societal challenges, which includes everything from job displacement to safety and accountability. And honestly, each one of these branches is a huge field of research all on its own. And the societal questions, they're massive. This isn't just a technical challenge, it's a geopolitical one, with an intense tech race for dominance already underway. It's an economic one, forcing us to ask some really profound questions about the future of work. And critically, it's an ethical one, raising these urgent debates about things like autonomous weapons and the desperate need for regulations to keep us all safe. So, this is the moment we're in. The line between our digital tools and our physical world is, well, it's dissolving. The AIs that we built in the cloud are now stepping down onto the ground, ready to build, to move, and to work right alongside us. And that leaves us with only one question left, but it's the most important one. Our tools are coming to life. Are we ready?
Let's just jump right in with the big question, the one that this kind of tech forces us to ask. I mean, it sounds like something straight out of a sci-fi movie, right? But what we're about to find out is that the answer, well, it's getting more and more complicated with each passing day. So here's how we're going to break it down. We're going to follow a patient's journey from the planning stage all the way through to recovery. And then we'll zoom out and tackle some of the huge hurdles and, the really deep human questions that come along with all of this.
All right, section 1. So how is this actually happening? How is AI getting a foothold in such a critical space? Well, it really boils down to two things: a push for insane levels of precision and a kind of personalization we just couldn't even dream of before.
Look, the simple truth is, even the most brilliant surgeons are still human, right? They get tired, their hands might have the tiniest tremor, there are just physical and mental limits to what a person can do. And that's the key thing to get here. The goal isn't to kick the surgeon out of the room, not at all. It's about giving them a powerful new tool, a way to overcome those human limitations using just the raw power of data and massive computation.
Okay, so where does it all begin? Well, it's not actually in the operating room. It starts way before anyone even picks up a scalpel. We're talking about the preoperative planning phase. This is absolutely where the groundwork for a successful outcome gets laid.
For the longest time, this part was basically an art form. A surgeon would get these flat 2D images, your classic CT scan or X-ray, and in their mind, they'd have to construct this whole 3D model of what's going on inside the patient. It was all based on their own hard-won experience and their gut judgment.
But now, things are changing. Think of AI as like a master architect for the body. It crunches through thousands of those scan images and builds this incredibly detailed, custom 3D model for that specific patient. And get this, surgeons can then use that model to do a full-on virtual dress rehearsal of the surgery. They can spot problems, fine-tune their approach, all before making a single cut.
And if you want to know just how precise we're talking, check this out. For something as insanely complex as spinal surgery, this kind of 3D modeling can get the measurement error down to half a degree. Just think about that for a second. Half a degree. That is a mind-blowing level of accuracy.
All right, so we've got the blueprint. Now let's step inside the OR and see how it all comes to life. This is where the magic really happens, where that incredible human experience meets cold, hard robotic precision.
So in the operating room, what you really have is this amazing partnership. On one side, you've got the surgeon, with all their years of training, their intuition, their ability to make a split-second call. You can't replace that. But on the other side, you have the machine, an AI-guided robot that is perfectly steady, never gets tired, and can adjust on the fly based on a constant stream of live data. And I want to be super clear here. This isn't science fiction. This stuff is real, and it's being used in operating rooms right now. You've got systems like Mako, which gives surgeons haptic feedback. It's like a gentle, guiding force on their hand to make sure a knee replacement is perfect. Then you have AR navigation that literally projects the surgical plan right onto the patient. It's really like giving the surgeon a super steady hand that's being guided by the brain of a supercomputer. And does it actually make a difference? Oh yeah, the results are real. There was a study out of Stanford that looked at complex spinal surgeries. They found that using an AI-driven robotic system cut the time needed to place these tricky little things called pedicle screws by 42%. And it did that while keeping complications super low. That's a huge deal.
Okay, so the surgery's done, but AI's job isn't over, not by a long shot. In fact, it's now starting to completely reshape what happens next, that whole journey of healing and recovery. It's making it way smarter and way more personal.
So instead of that old-school, one-size-fits-all recovery plan, AI is changing the game. It can look at a patient's data and predict their risk for things like infections. It can build a custom rehab program just for them, one that actually changes and adapts as they get better. And it can even let them recover at home, using wearable sensors to keep an eye on their progress. It's pretty amazing.
And again, this is not just an idea on a whiteboard. There was a study on ACL surgery, a really common knee operation, and it found something incredible. After a whole year, the patients who used an AI-guided rehab program at home actually had a better recovery than the people who did the traditional in-person physical therapy. So yeah, this stuff works.
Okay, at this point you're probably thinking, this sounds incredible, revolutionary. So, if it's so great, why isn't this in every single hospital? Why isn't every surgery done this way? And that's the perfect question, because it gets us right to the big hurdles and the hidden dangers.
So yeah, let's unpack that. Why isn't this tech everywhere?
Well, for starters, the price tag is astronomical. These systems are incredibly expensive to buy and maintain. Then there's the data problem. Medical records are all locked up in different systems in different hospitals, which makes it a nightmare to get enough good data to train these AIs. Plus, you've got the huge risk of algorithmic bias. If you train a model mostly on data from one group of people, it might not work well or could even be dangerous for everyone else. And then there's the black box problem. And this black box issue is a really tough one to crack. It's this situation where the AI gives you an answer, a recommendation, but nobody, not even the people who built it, can tell you exactly how it got to that answer. Now, put yourself in the surgeon's shoes. You're responsible for someone's life. How can you trust a recommendation if you don't understand the reasoning behind it? It makes it almost impossible to take that leap of faith.
So, that brings us past all the tech issues and into something deeper. Something much more personal, much more human. Because at the end of the day, this isn't just about cool robots and smart algorithms. It's about us, our bodies, and maybe even our sense of who we are.
Yeah, we've talked about the challenges for the doctors and the engineers, right? The cost, the data, the trust. But what about the person who's actually going through this? What does it all mean for the patient?
Because for the patient, the questions are a lot simpler, and maybe a lot scarier. It's, who am I now? When a piece of intelligent technology is inside you, helping you live, helping you move, it starts to blur the lines. It can really make you question your own identity. And this quote, it just says it all, doesn't it? It comes from a patient who has a smart implant. On the one hand, there's this profound gratitude, this feeling of getting a second chance. But then, on the other hand, there's this nagging worry, this fear. What if it fails? What if I can't live without it? It's that constant back and forth between hope and anxiety. And that really is what this all comes down to. As our bodies get smarter, as we start to merge our own biology with artificial intelligence, what has happened to the self? We're not just fixing bodies anymore. We're stepping into a whole new era, one that forces us to look at one of the oldest questions there is, but through a totally new lens. What does it actually mean to be human?